So now that we know how to check our fuses and our fusible disconnect, let's talk about power passing versus power consuming. Now, a power passing device is anything that takes power and allows it to switch through it to a power consuming device. So a switch would be a power passing device. It's taking power, and it's that power, half of that power anyway, is going through the switch and then going to this terminal strip where it gets divided to the different parts. Your contactor is a power passing device. It's taking power from one end, and when the contactor pulls in, it sends it through to the other end and then gets distributed to a part. Your contactor relays are power passing devices. Your thermostat is a power passing device. Your compressor is a power consuming device. A light bulb is a power consuming device. It consumes power so that it can glow and create light. Your furnace, well, in this instance anyway, we're gonna say it's a power consuming device. It is a power consuming device normally, but ordinarily we would be connecting to a gas valve or something like that, so that we can light the fire and create warmth. But because we're using a light bulb, it just makes it a little more difficult to understand. Your fan motors, whether it's your indoor fan or your outdoor fan, those are power consuming device. They consume power within the motor so that that motor can spin and move air, whether it's moving air into a space that you're trying to cool or heat, or whether it's exhausting air so that you can remove the heat from your refrigerant and out into the atmosphere. So how do we check a power passing device? Well, we check a power passing device, we can do it in a couple of ways. And one way we can do it is just like we did with our fuses. We would pull our switch out and turn it. Now this switch, this side here is a ground, so we don't have to worry about that. This switch is controlling the hot side of our electrical. If I can just get it to sit in here. There we go. So we're taking our hot side. Our neutral side is right here. I don't know if you can see it, but it's wire nutted together. We got our neutral coming in, wire nutted to a second neutral, white neutral line that comes out and then hits our bus bar. So we're taking our hot side off of our power cord here, and we're going into the switch, and then we come out of the switch here and we go into our bus bar eventually anyway. So one way we can test it, like I said, to see if our switch is good, is again, we go to continuity. Move this up here so you guys can see it a little better. And we take our probes and we put one probe on the incoming and one probe on the outgoing side of the switch. Now, right now, our switch is off. So we should get nothing. If we put a probe here and we put a probe here, we get nothing. No beep. We're reading OL on our meter. Now, when we flip the switch on, that essentially is like having a completed wire. So like I showed you with the fuse, where you've got one solid piece of wire, your switch needs to be thought of in the same manner. Your switch is a solid piece of wire, and this either cuts that wire in half or it makes the wire complete. So right now, because the switch is off, it's been cut in half. But once we switch it on, now we've got continuity. We got the beep, we're showing continuity on our meter, so our wire has been made complete, which means, I'm going to turn this off, but what it means is that your power is coming in here, it's being completed, going through here, and being allowed to pass through. That's why we call it a power passing device.